A significant outbreak of severe weather is possible over the northern New England area. Also, parts of northern New York and Canada are included in this risk. There is currently an enhanced risk of severe weather in the New England area as well as in New York and Canada. Well, not quite Canada, but like its proximity to Canada is very close, and we are expecting some tornadoes as well as some strong winds and significant hail to develop from these storms that will be crossing over the Canadian border to the United States in the near future. We will be going over the risks that we'll see with this event in this video through the models, through the SPC outlooks, and also some other risks that are not confined to the New England area that will also be considered as impactful for parts of the United States as well. Now, one thing I will note before we get into this forecast, you do have to realize that there will be a live stream that I will be conducting on the severe weather impacts to northern New England in this area. So, we will try to make sure that we put this information in an understandable manner in this video. However, we will also try to make it in an understandable manner as the events are going on in our live stream forecast and eventually our live stream coverage. First, we'll be going over our SPC outlook, which determines the risk for multiple areas in the United States throughout the days that are upcoming in this series of severe weather events. As you can see here, we have an enhanced risk that is currently positioned over Maine, New Hampshire, Vermont, and New York, as well as a marginal risk that is currently positioned over Florida. And we also do have another slight risk that has just been issued for Montana, and areas as such are under a thunderstorm risk. We are looking for mainly wind as well as a potential for tornadoes in the enhanced risk, and mainly a hail risk in the area that is positioned under the slight risk, as well as mainly a wind risk in the Florida area. Well, actually, now looking at this, it's mostly a wind risk in Montana too. But you can see with our different parameters that determine our risks for all of these areas, you can see there is a 10% significant SIG 1 risk for parts of Maine and a tiny bit of New Hampshire. These areas are expected to see strong tornadoes. Not necessarily very much strong tornadoes, but these areas are expected to see at least some potential for strong tornadoes. That's usually what is indicated with a 10% hatched risk. We also do see a 5% and a 2% hatched risk around that area, which encompasses parts of Vermont, New Hampshire, New York, and also more parts of Maine, including cities like Burlington, Lewiston, Bangor, Auburn, and Plattsburgh. These areas are expected to see strong tornadoes as well, but they'll be less frequent and farther apart from each other, as you'll see with this lower risk. In the 2% that isn't hatched in any way, these regions are not expected to have strong tornadoes, and they'll be very far and few between if there are tornadoes. Of course, moving on to our wind risk, we do see that there is a 30% hatched risk area for SIG 1 in the same areas basically that are under that tornadic risk. These areas will be experiencing up to 75 mile per hour or more winds with this system, and with any storms that develop out of this system. Therefore, we'll be seeing some wind damage, even not from tornadoes, possibly just from straight-line winds that will move into the area from Canada. We also do have a 15% risk around that, and a 5% risk around that too. And a 15% risk is also present for wind in Montana, for areas such as Great Falls. These areas will be experiencing some winds as well. However, since this is not hatched with a SIG 1 risk, this means that the winds will most likely be in the 60 to 75 mile per hour wind range. Still severe, however, not quite as severe as what we'll be experiencing in the Northeast. We also do have a risk in Florida, however, that will be very sporadic, as there is not a lot of confidence in that region having much winds. We also lastly have our hail risk, which isn't as prominent as the other two factors. However, it is still notable as it is still mainly in the Northeast area, in New York, Vermont, New Hampshire, and Maine. You can see here there is a hatched risk for 15 SIG 1 that exists for areas such as Burlington, Plattsburgh, Colchester, South Burlington, and Waterville. Also, there is a small hail risk in Montana. Sorry about the reload. These areas will all have to be alert for the different factors that will play into the severe weather outbreak that we'll likely see over today and possibly the next few days, although not to quite the extent as we were expecting with today. We do also have a marginal risk that I was briefly alluding to before, over here in New Jersey, Pennsylvania, New York, basically in my area. And you can see there isn't much of a tornado risk, but there is a wind and hail risk with this system. So we'll be watching for some small windy conditions and a bit of hail that will penetrate some vehicles, but not to the point where they'll break the windshields. So, we are watching for all of these severe risks that are upcoming. However, past that, we're not actually expecting much severe weather. We're mainly expecting today and tomorrow that will be the main risks for severe weather over the next few days. And that probably indicates a part of the system that we're experiencing and the part of the pattern that we're experiencing over the United States is dictating how we won't be able to see severe weather in many areas and many widespread areas besides maybe the northern United States over the next few days. If you look over here at the models and go over to the winds in the upper atmosphere, let me look at that real quickly. Okay, here you go. If you look over here and look at the upper wind across the United States, you can see that most of the wind is confined to the northeast area of the United States, although a little bit of a jet stream also exists in Montana too. However, you can see these areas are broken apart by a ridge that currently exists over the central United States, over here where my head just circled. And you can see there isn't a lot of winds in the upper atmosphere in this region. There's only a couple of areas that have slight wind vectors, and these areas don't really have any conducive winds in the upper atmosphere to produce many storms. These maybe will just be some rain showers at the most. And that's part of what the ridge is showcasing in this area. We're not going to see a lot of severe weather in the typical areas, but far in the north, and also in Canada, we will be experiencing quite a bit of winds howling across the top regions of the atmosphere in the northern United States. And you can see there is a much more wind vectors in Canada as well, but you can see what's causing tomorrow too. You can see the different wind vectors in that region. But going to our latest model run, you can see that there is quite a bit of winds in this region that last for quite a while, and that's mainly going to be where our severe weather will impact. So, we are mainly expecting the wind shear to mainly exist in the northeast corner of the United States, as well as any storms that develop due to this wind in the upper atmosphere not really moving down to the surface because it doesn't exist in other areas. But over here in the northeast, it does exist and will manage to affect the areas below it. You can also see from this model run, you can also see some moving of this warm sector. And you can see that these wind barbs are actually moving in different directions over this whole region that I'm circling with my head. In that region, you can see, specifically in the northeast, you can see that there is some separation of those wind barbs, which indicates not only some wind shear, but flow that will indicate an area where storms need to build back up to get rid of the void that exists in the region from those wind barbs. So, what exactly does this mean? When the storms build back up, that means that storms will become strong enough to where they will advect and also start to drop some hail due to how far up they are moving. But that's not the only effect. We also do have a stronger storm if they build up, and that will indicate that a storm is becoming healthy over time. This is the NAM3K, however. This is not the only model one we can use to determine height. And you can see on the HRRR, there is also a notable amount of height in these regions, even before the main severe weather setup begins. But you can see, as time moves on, Let me just see. There is a new model run, so let me use that. You can see there is quite a bit of wind in this region and a lot of flow. You can see this is sort of forming a semicircle, and that kind of indicates that there is a strong trough in the region over the Northeast. That strong trough will mainly transition all threats into wind threats, as there's not really a big separation of those wind vectors later on. However, early on, when these wind barbs are more widespreadly moving away from each other, they're in different directions, that will indicate that there is much more flow moving from the northwest, and this will cause more of a tornadic potential. However, the problem with this, there's not a lot of winds in the upper atmosphere. So, we won't have the most favorable conditions for severe weather in these regions. However, it definitely will be enough to where tornadoes will develop initially, and then wind will take over the main threat later on. So, what exactly will we see with these dynamics and with the storms from this wind? Well, you can see over here, storms don't develop until later on, around, what is this, like 5 p.m. or 6 p.m. Eastern Daylight Time. And this won't be in the United States initially. This will be in Quebec initially. However, as these storms move south, which is the reason why we're seeing this risk protrude into parts of the northern United States, we're not really seeing them move the typical directions from northwest to southeast or northeast to southwest. Or, wait, no. We're not seeing them move from northwest to southeast or north or southwest to northeast, but rather we're seeing them move all the way from the north down towards the south, maybe a little bit to the east from there. And that's mainly because of our trough. It's mainly because our wind vectors are moving in that direction. Our wind vectors are coming from the northwest and then flowing out in this way, flowing out up and down towards the east. So that will generally mean that the storms will have to build up as they move through that warm sector, which is positioned from the west to the east, and therefore they'll have to move south. So that's generally what we're seeing with these storms, and they'll have a little bit of an east trajectory as that flow is mostly positioned to the east. However, the storms will have to go through that warm sector due to the lower level winds from the north. You can see that there isn't quite a lot of storms in this region. Let's zoom in on the Northeast specifically. You can see these storms aren't looking that incredible, besides the amount of wind they might develop in this region of northern New Hampshire, Vermont, and Maine. We're not really expecting many supercells on this model. However, they will develop to an extent. Definitely not as strong as what models were hinting earlier, but we are experiencing some of the wind threats still existing in this region. However, let's look at our environment and see if supercells are still possible. They're just not being indicated on this model. You can see over here, wrong thing. You can see over here that there isn't much of a cap in place in this region. There is much of a cap in the south. However, in this region, there's only small corridors of CIN, which is similar to the cap. And that will prevent the storms from developing unless if they're in small pockets, which indicate that that is the storm. There is some cap in the atmosphere from the storm itself. You can also see from the Cape, there is quite a bit of Cape. Definitely not the most I've ever seen. However, it's definitely enough for storms to develop, especially in this region. And you can see it's much more initially. It's around 2,000 joules per kilogram. Most of the conditions will be in Canada, so definitely be alert if you live in the Montreal area. Also further up north towards Quebec City, those areas might actually have the worst time compared to the United States with hail and possibly some tornadoes. But you can see there is still some favorable conditions in effect for some areas in Maine, New Hampshire, and Vermont. If you look at the storm relative helicity, there's also quite a bit of that too, which indicates that there will be a lot of wind shear for these storms that they will create, as well as wind shear that already exists for these storms. And if we look at the significant tornado parameter, it actually is kind of high in these areas, specifically near the Island Pond area in Vermont. That area is actually experiencing up to 3 significant tornado parameter, which means that there is some conditions that are combining together to create potentially some significant tornadoes. Now, this area is much more confined than where our 10% is over here, but this is not our only model. If you look at the NAM3K, you can see this is definitely not as confined in this whole region in a circle from northern New York into western Maine. That's definitely not as confined of the significant tornado parameter, which means tornadoes that may be significant would spread over a much larger area if this model was to come to fruition. And we might be able to see that with the reflectivity and the storms themselves. You can see they develop not until later, but you can see these storms are much more isolated as they move through. And that might indicate that there will be more of a supercellular potential with them. However, I'm not expecting, it does seem like there is more of a limiting factor with these storms on this model run besides the significant tornado parameter. So it looks like there's not as many storms to take up the environment in this region, in this case. However, we are still noticing that there are storms to develop and those will create wind. Let's take a look at that wind. You can see from our wind, let me just get it, you will be able to see from how fast the winds are that this will be a powerful windstorm. You can see over here as we go to around 5 p.m. the winds aren't especially strong. However, as these areas move south, you can see the winds start to intensify near the Sherbrooke area and then later into the United States in New Hampshire and Maine. You can see there is up to 30-mile-per-hour winds that's about 18 knots here. But this, I don't think, is the lower level. So let me see if there is, that might be the wind shear. That might be like the wind shear and the wind in the upper atmosphere. Let me see if I can find it in the low. This is as low as you can go. No, wait, that's not gonna work. Okay, let me go to this. Let me go to this. Wind gust. Okay, I found it. So, this is where you'll see our wind gusts on the NAM3K. And you can see there is some powerful wind gusts in this region. You can see up to 45 knots is possible in northern, or western Maine, rather. And this will contribute to around 60-mile-per-hour winds, which will be indicative of some severe conditions. You can also see these look like non-thunderstorm wind gusts over Lake Ontario. So that might also be a factor with these storms dragging down air from north in Canada into the New York area. That might also cause some winds in upstate New York, and later on in these regions in New Jersey and Connecticut. But you can see there definitely isn't as widespread winds anymore as what the models probably were initially showing, but there still probably is a wind threat. And also a non-thunderstorm wind threat. I will mention there is a non-thunderstorm wind threat with some of these storms. Now that's enough with our northeast risk. What about our tropical risk? Because there is technically some tropical potential in the Gulf of Mexico, or America, whatever you want to call it, in this area. You can see over here, there would be a hurricane in the eastern Pacific. However, that wouldn't impact land. However, there is some signal in some cases for a tropical system to develop. It's just not developing here because the models switch around a little bit. But there will be a lot of tropical moisture. It's not necessarily a tropical storm that's going to develop, but it's going to be a lot of tropical moisture that tries to develop from these systems. The problem is there's such a ridge over the United States that I feel a tropical system isn't very likely. But you can see a little bit of a low near South Carolina and Georgia there. But the main concern here, I honestly would say, is rain, especially in the Texas region. You might be able to see from the 24-hour accumulated precip that there is quite a lot of rain in the Del Rio area, as well as to Big Bend National Park. This can reach up to 3.5 inches, and possibly more. I think that's in inches. Yeah, that's in inches. That might reach up to 6 inches in some parts in the Del Rio area over 24 hours, which definitely might cause a lot of impacts. And if you look at overall precipitation, that would be even higher, and it's still trailing in the same areas. There'll still be a bunch of storms in the same exact areas in the western Texas region, and that will impact those regions a lot with flooding, which we've already experienced a lot this year in the Del Rio area, as well as other parts of Texas. But you can see up to 7 to 8 inches are possible by Saturday, which definitely will mean there will be some flooding concerns in this region, since the same areas are being impacted over and over again. However, one thing I do want to point out, past this point, we're not really going to see much in terms of the wind vectors across the United States, and that's why we're not getting as much weather over the next few days. If you look over here at the GFS and go throughout these and see the winds in the upper atmosphere over these areas, let's look at 500 millibar. You can see most of the jet stream is located in Canada or the northern United States, and this is initially when it's still impacting the United States' severe weather. But you can see there is also another low that tries to develop with this ridge on the periphery of this ridge near Washington and Oregon, and this will also try to develop some winds. However, I do not expect that this will cause much severe weather. Maybe a little bit of severe weather will be possible in the UP of Michigan on Saturday. However, I'm not expecting much besides that. I do think that our main pattern will shift towards Canada, and these main areas of wind vectors moving in different directions will be into Saskatchewan and Alberta, which is still concerning for them. However, I don't think we're actually going to see much severe weather, as this is a weird position for it. Maybe some in Minnesota and Wisconsin later on. So, that's generally what we're seeing. But one thing I do want to take a look at, to be more technical with things, I do want to show a photograph in the region of Vermont, New Hampshire, and Maine. So let's look in our Maine area and see that photograph. There is a marginal tornado risk there. Let me get a better sounding, because that might have been somewhat contaminated. This is better. I think this is the same, actually. But you can see there isn't as much of a tornado risk in this region. It is notable, but it definitely could be worse. And if we look at the newest model run, let me look at the newest model run, because that's probably more accurate with what we're seeing the trends to get. If you look over here in far western Maine, there is a tornado risk. However, I noticed that the storm slinky isn't moving towards the left that much and then moving to the right. That kind of indicates that there's some difference in winds in the upper atmosphere compared to the lower atmosphere. There is a classic Hooper-cell position here with the SR wind versus height. And you can also see there's a bit of a curve on the photograph. The temperature to dew point ratio is also not bad. And also, the Cape is definitely not bad, but we already saw that. And there definitely is some supercell parameters and significant tornado parameters, but you can see this is a little bit contaminated. So maybe the parameters are being exacerbated a little bit by the contamination of the radar. Let me see if I can find a less contaminated radar. This is a little better, but this still is showcasing a tornado sounding. But you can see that Storm Slinky, again, is not moving to the left initially, and there's still a bit of a dew point temperature spread. It's not anything insane. So, I do think that there will be a tornado risk initially, but I do think that line cluster, it really depends on how quickly those wind vectors start to move in the same direction. Those wind barbs move in the same direction will cause the wind threat to start to increase and make those storms converge into a line. But anyways, guys, that's about it for this video. Thank you guys so much for watching. I hope to provide accurate weather coverage, even without a meteorology degree, in this video, and also in the live stream that I'll be conducting in a few hours, possibly like maybe an hour from now, as the severe weather starts to kick up. So, thank you guys so much for watching. Please be sure to subscribe, turn on notifications. If you don't know what the notifications look like, it's a bell icon right next to the subscribe button. Also, make sure to like this video. I don't care if you dislike. Well, you can't dislike anymore, so never mind when I said that. Also, make sure to... make sure to subscribe. I already said that. And I hope you realize that the Moist Data on the Road freeway tries to provide accurate coverage on the weather, but it also provides more reason to become happy when you need to, and to become aware when you need to. That is the goal of the Moist Data on the Road freeway. There's going to be some bumps, but there's going to be some smooth rides. Thank you, guys.